will metabolize the waste from the people that live around there differently. So if, for instance, these microbial fuel cells have been used in Africa, and they use local microbes so that they metabolize the local waste from local people. So there's these two chambers, and then in between the chamber is like a matrix, and as the microbes consume the urine, then they excrete these electroactive byproducts, and then the electrons from those travel from the anode to the cathode, and it makes a tiny electrical signal, and that's how the electricity is generated. So they generate very small amounts of electricity, but when you've got a whole load of them, a whole stack of them, then they're useful, and it's substantial enough to do something helpful. One of the things that is often questioned with Yanis's lab is about how this gets to scale. But when solar power became popular, wasn't popular, solar photovoltaics generate such a tiny amount of power, but en masse, then they become really effective. So I think the same potential is possible with microbial fuel cells. And the brilliant thing about it is that it's recycling our own human waste. So we're really good at recycling different products and stuff like that, but we're maybe a bit squeamish, and we don't really think about how we can recycle ourselves. So if you're recycling yourself and generating electricity for your home, that's pretty revolutionary. So from an artistic perspective, we were thinking about, what does it mean to be a data microbe? How can we create an artwork that is based on the concept of this data as microbe, and what would that mean? So this is how I started thinking about how to create the software around for the project. So if we think about microbial consortia, how can we map that to data consortia? And we went through a whole kind of conceptual process of considering what that might mean, and how we could create this data bioreactor to mimic what was happening inside the microbial fuel cells. So the sort of digital version of the physical living system. And it was quite interesting to look at the idea of power, which seemed the most obvious one. But actually, there's loads of commonalities between microbes and data as a sort of system. So they have all these commonalities. They both move in different ways. They have different types of forms. They feed off other things. So that whole kind of idea that data begets more data, the same happens with microbes. They have more or less power. And in terms of microbes that generate electricity, it's electrical power, but in terms of data, it could be political power or social power, or power over making decisions in different ways in our society. And in the same token, they could be benign, or they can be malicious. So all of these things, I found it really intriguing that something that is intrinsically not living and binary, which is data, had all these kind of similar forms to something that is very organic and living and outside of our control, particularly these things like emergent behavior, the way that context affects how data is perceived. Context also affects how microbes can replicate and how they get to a sort of homeostatic state. So these commonalities made it then even easier for me to conceptualize the work as a data bioreactor. And this is the software framework that we came up with. In terms, there's data inputs. So the inputs are human urine. And the data from that is the urine flows, how fast it comes in and whether it's there or not, the presence. Environmental information, so that's temperature, humidity, geolocation. And then human inputs. So on the interactive one, you can sort of tap things and make things happen, and that will change the data system. And then just general monitoring of the microbial fuel system, so how much power is being generated at any one time. And all of that input goes into the sort of data ecosystem, and it gets processed in different ways and different using different parameters. And then the output is a set of data microbes that are animated. So the data microbes, they're audible, so they make a sound. And then there's also a metadata stream what is happening in the framework. So what this is all describing is just essentially how we got from microbial fuel data to a final animation. We used a bacterial foraging algorithm to sit underneath the way that the animation works. And this book, Natural Computing Algorithms, I got completely obsessed with it. It's a massive book. I don't know, have you seen it?
No, I haven't.
It's got all of the algorithms that replicate loads of different natural behaviours. Nicola, have you seen this?
And I'm sure Tim would be fascinated. It's possible he has seen it. I'm just going to take a photograph.
That's it. I've got a PDF of it.
Oh, yeah.
For review purposes.
I will review it.
It is amazing. Anything you can think of, like bees or different types of bacteria, or it's all in there. It's like phenomenal.
Like fractals and
and anything that kind of like that you want to set up a simple rule-based system to sort of have some kind of generative output. Very inspiring.
What is bacterial foraging?
So bacterial foraging is the algorithm when bacteria are just, say, on my hand, which they are now. What they'll do is they kind of like move around until they find food, and then they'll eventually sort of all end up congealed around the food that's there. So when you see biofilms created, like mold or something like that would be another example. The foraging bit is them moving slowly across to find where the food stuff is. And so they call that bacterial foraging. And within that foraging, it can be like, is there food here or not? Is there a lot of food here? Are there other things around me that are also eating that food? So it can be as simple or as complex as you like. You end up with these different rules. And that algorithm generates the basic movement in the animation. And then the data from the microbial fuel cells makes it different all the time. So I think probably I should show you the animation that will make it a little bit clearer. Is that coming through? So this is in the installation. This animation is included in the physical structure as 5 little screens. And what you're seeing here is a kind of representation of the matrix, which are those stripes behind, and then all of the different bacteria that are moving around on top. And this feeds, the data that's feeding this is the level of electricity being generated by the microbial fuel cells. And if you want to have a look at that anytime, we can see how much the stack is generating, what useful energy has been accumulated. And that flashing yellow means with the system that is built, there's only a certain amount of storage that the hardware can keep. So when it gets full, then it dumps the energy so it can like store it back up again. So usually when I make work, I don't have this kind of data overlay. Normally it's more of an abstract experience, but because this is for a kind of an art crowd and a science crowd, we built in the ability to overlay information so that you could watch things as they were changing in the lab. And one of the other things you can do is flip it into simulation mode. And do things like add food. I start adding food into the system, you see these kind of little representations of urine flowing across the screen. And as they move along, the bacteria, some of them will start to follow, eventually they'll start to follow the food, and some of them will just carry on sticking to the mesh shape and building up the biofilm. this animation is, although the whole thing is constructed by me, the way that the animation is working, the way that the sound plays is completely controlled by the data from the microbial fuel cells and what they're doing at any one time. I'm going to flip back to my slides and show you a picture of the installation itself.
Is the sound driven by it as well? Or?
Yeah, so the sound is driven, the sounds are attached to each one of the microbes, so they have different sound samples. And actually the sound samples come from are recycled as well, because they came from a Polish composer who used to make music concrete for one of the old Polish radio stations. His name is Bogusław Schaefer. Schaefer. Yeah, so he was a famous music concrete composer, and they recently digitized all of his work and put it online for free for remixing. So yeah, it's an amazing resource. And it was Matt Moss that remixed it.
I think I missed a few points on it. So what's driving the movement of the individual bacteria?
So the movement of the individual bacteria is based on the bacterial foraging algorithm. So they'll move around looking for food, and the food comes into the animation. Like the user, you can interact with it to dump food, or the food will come through randomly.
So the generation of food comes from the fuel cell?
It comes from the feed pump in real life. So the system has got the urine going into it, and whenever the feed is pushed through, we pick up the data. They get a data flag, and then it drops food into the animation as well. So it's like it's like a digital twin. Well, in this work here, there's 15.
Oh, right.
There's 15. If you look inside, let me just. Yeah. So this is. It's got a whole series of LEDs, and while it's in action, it kind of like glows. The whole orb glows, and all of the power, the computer that's harvesting the data, all of the LEDs, and the rest of the sensors are all powered by the system itself. If I zoom in a bit.
That's like a similar.
Self-sufficient.
Also poetic.
It's not far of a similar sort of space take to PV, right? I mean, it's not.
Yeah.
Even, yeah.
No, I think if it had a load of more investment put to it, it could definitely do that. And then the vision for this. So Rachel, the architect, and Yanis have been working on. Imagine if you had one of these fuel cells was a brick, and it was and you had a wall of them, and then the wastewater from your toilet was plumbed in to the wall, and so your house was effectively just generating some of the electricity that you need to live with, and it was kind of all a sealed system. So it solved the problem of getting rid of your liquid waste, and it would be just a really cost-effective way of generating power. But there's a sort of, I'm not sure why it's not. Some people are investing in the development of it for places, for sort of refugee camps. So for humanitarian uses, you can imagine it would be a really useful system to have in those kind of places, because you get rid of the waste, you'd also generate power, and then you could have connectivity. So it could be used to fuel internet connection and stuff like that.
And can I ask, are they looking at solid fuel as well?
There is poo power, yeah. They're not. The lab I'm working with were not. And honestly, the lab smelled enough as it was. I was quite pleased that it wasn't the other one, the solid matter. But it's really fascinating. It's kind of, I'll zoom in. So that these white boxes are the MFCs. And already in the last few years, they've refined them to make them quite a lot smaller, but to still be generating the power. So looking at sort of changing the shape of the surfaces, like if the biofilms could be more folded, then you've got more surface area, then maybe it would generate more electricity, but in a smaller space, all of those kind of things.
Are the components, very expensive?
Yeah, no, it's all, so they did, someone's done a project sort of inspired by this, where they built microbial fuel cells just from like recycled materials. Mm-hmm. So it's basic electronics, just picking up the power. and then just literally sort of 2 chambers, and then the matrix, this sort of mesh stuff that goes in between. And that's
Maybe
it.
People go straight to the people with it. You know, it could be that, like, the geekery, for example, could set up an industry for it. There'd be lots of people say, yeah, I wouldn't mind keeping my home, or, you know, getting a license or whatever.
Yeah.
How much energy do you get from a donation?
So yeah, not very much. So this, there's 15 cells in here, and Arjuna, the engineer who built the hardware, he said that it would take about 4 days to charge a mobile phone from flat to completely full, a modern smartphone. With that. Yeah, but if it was, if the phone was on, it could sort of like top it up, but to like completely charge it from scratch, it would take a little while. But we had all these LEDs running, and like effectively, it wasn't a Raspberry Pi, but a little computer, a little controller. And it was running on that. And because the V&A we used synthetic urea for this project, because the V&A were quite funny about having human waste in their music. And we didn't have a pump because it needed to be just a sort of sealed system. And it lasted and constantly powered for the whole 3 days it was there without any issues. But the fuel cells, if they run out of, so if they dry up and they run out of anything to sort of feed off, they just go into a dormant state, and even months later you could go and just wee on them and then they would start up again. They'd do the same thing. So it's been interesting for me because the whole project has been all about how to keep things really simple and light. And even in terms of coding the animation, we were like, how can we make it really simple so it doesn't use lots of heavy graphics and stuff. And one of the ways that we did the animation that you saw, the little kind of flapping things, was just to use really simple SVGs. And they're just 2 tiny Bezier curves that have got 2 points, and then all we do is pull the handles around these circumference around here. You just pull them, and just by moving that slightly, or by the data moving them slightly, you get this kind of quite organic motion. So even the way that we coded it was thinking about, you know, how simple can we get it to make something emerge.
What programming environment did you use?
So we built we used Django for the back end, and it's mainly Django and JavaScript. And that's it. And it's online here. And what comes out is like a sort of grey water, which can be used as a sort of just for like grey water stuff. You wouldn't want to drink it, but it's kind of not toxic. And then the other bit that comes out is like a sort of disinfecting nitrate stuff, so you can use it as a fertilizer. But there's a whole history of humans using urine for all sorts of things, like in early day farmers, before we had the sewage infrastructure. People would just wee in buckets and stuff, and the farmers would go and collect them and then use them in different ways. And it's only the more we've distanced ourselves from our own bodily waste that we've stopped thinking of it as a useful thing.